right, so this is our walkthrough for the basic implicit differentiation homework assignment. There's only 4 problems here. And so we're just going to jump right in here. We're supposed to be finding dy dx for each of the equations that's given. So our first one here is 3x squared y plus 5y cubed equals 9. So since we're trying to find a derivative with respect to x, that means that every time we take a derivative of the y terms, we have to add the dy dx to it. That's the implicit differentiation part. It's the chain. So we'll start with 3x squared y, and we'll note that that is a product of 2 different things, 3x squared and y. So we'll have to use the product rule for it. So we'll start with the 3x squared, and then we're multiplying by the derivative of y with respect to x. So that's dy dx, right? The derivative of y with respect to y is 1, and then the derivative of y with respect to x is just dy dx. So that's the chain rule. 3x squared dy dx, and then we'll add to that the derivative of 3x squared, which is 6x, and then times y. And this time we don't add the dy dx to it because we didn't take the derivative of the y term. Then we have the plus 5y cubed. So plus, well, the derivative of 5y cubed with respect to y is 15y squared, but then we have to multiply that by the derivative of y with respect to x. And then on the other side of the equal sign, the derivative of 9 is just 0. So now we will gather all of our terms to that have a dy dx in them to one side and everything else to the other side. So that's going to look like 3x squared dy dx plus 15y squared dy dx is equal to negative 6xy. And then we'll factor out the dy dx from the left-hand side, leaving us with 3x squared plus 15y squared. And when we divide, we should get pretty much our final answer. We'll note here that 3x squared, 15y squared, and 6xy are all divisible by 3, right? So we should be able to simplify this down a bit. So we'll write it without the simplification first, but we have negative 6xy over 3x squared plus 15y squared. And like I said, we can simplify that down to negative 2xy over x squared plus 5y squared. And so there's our first problem. So whenever we take the derivative of the y term with respect to x, we have to attach this dy dx to it. So here we've got y to the 4th. Well, when we take the derivative of y to the 4th with respect to x, we first do it with respect to y, so 4y cubed, but then we multiply by dy dx. And the same with the minus y cubed, that should become minus 3y squared, the derivative of y cubed with respect to y, times dy dx. On the other side, we just take our derivatives as we normally would. Derivative of x squared is 2x, and the derivative of 5x is just 5. We'll factor out our dy dx on the left-hand side, giving us 4y cubed minus 3y squared. Oops, I don't know why I wrote an equal sign there. But we're factoring that out. And that's equal to 2x plus 5. And then now we just divide by everything that's on that dy dx side except for the dy dx. So dy dx, in this case, ends up being 2x plus 5 divided by 4y cubed minus 3y squared. Same process here. Our derivative of y squared is just going to be 2y times dy dx because we're taking the derivative of something with y in it with respect to with respect to x. And then the 3 sine y, well, the derivative of 3 sine y with respect to y is 3 cosine y, but then we have to multiply that by dy dx. Noting that dy dx is not inside the argument of the cosine, right? It's cosine y times dy dx. And then we'll subtract the 4x cubed. Now we can just gather everything to one side. Now, it doesn't really matter which side you bring everything to. I tend to try and move things around so that I have positive terms. So what I'm going to do is I'm going to bring the 4x cubed to the left-hand side by adding that negative 4x cubed over. And then I'm going to subtract the 2y. So I'm going to have 3 cosine y dy dx minus 2y dy dx. Now, if you decide to leave the 2y on the left side and just subtract the 3 cosine y dy dx, that's fine too. It doesn't really matter. But I just think this looks slightly cleaner. So that's why I choose to do this most of the time. We'll factor out the dy dx, leaving us with 3 cosine y minus 2y on the right-hand side. And now we'll divide by 3 cosine y minus 2y. So our final answer is dy dx is equal to 4x cubed divided by 3 cosine y minus 2y. And our last one here for this first assignment has actually got quite a few little product rules in here that we're going to have to deal with. Starting with x squared times y to the fourth. So x squared times y to the fourth, when we take that derivative with respect to x, is a product rule problem. So it's x squared times the derivative of y to the fourth with respect to x, which means take the derivative with respect to y, and then multiply it by dy dx. Then we have to add to that the derivative of the x squared, which is 2x times y to the fourth. Now we'll do the y cubed times x portion of it. So that's plus y cubed times the derivative of x. Well, the derivative of x is just 1. So that'll just be y cubed. And then plus the derivative of y cubed, which is 3y squared. And since it's with respect to x, it'll be times dy dx. And then we have to multiply that by just the x. Then on the other side, we've got 2xy. So normally I'll just treat the 2x as the first function and the y as the second function. So we'll have 2x times the derivative of y, which will be dy dx. Then we'll take the derivative of 2x, which is just 2, and then multiply it by the y. And again, that y doesn't get a dy dx because we're just multiplying by y, not taking its derivative. And then at the very end, we have the minus x. So we end up with minus 1. So now we're going to gather all of the dy dx terms to one side. So that means this one is going to get brought over to the left-hand side. And I'm going to bring my 2xy to the fourth and my plus y cubed over to the right-hand side. So as I do this, I'm going to kind of clean up some of these things. So this is going to be 4x squared y cubed dy dx. And then we're still going to have the plus the 3y squared and the x. So that's going to be rewritten as 3xy squared dy dx. And then we're going to subtract 2x dy dx. And that's going to equal, on the other side, we had a 2y minus 1. And we're going to then subtract the 2xy to the fourth and subtract the y cubed, right, these two terms right here, that did not have the dy dx's attached to them. Now we can factor out our dy dx. So we've got 4x squared y cubed plus 3xy squared minus 2x. And we still have all that same stuff on the right-hand side. And then to finish it off, we'll just divide. dy dx is equal to 2y minus 1 minus 2xy to the fourth minus y cubed all over 4x squared y cubed plus 3x y squared minus 2x. And that is our final answer. And that's the last problem in this first basic implicit differentiation homework assignment.